All right, welcome back. I'm Agent Ultra. Nice to see you again. I'm here to work on stuff. I build stuff in Haskell, a functional programming language. Sometimes other things as well. But that's mainly what I do. And lately, I've been working on a little project to see if I can build a MUD server in Haskell. What is a MUD, you ask? I'm glad you asked. It is a multi-user dungeon, which is an old school name for what would eventually become like a massively multiplayer online game. Yeah, getting all my acronyms turned around upside down, but yeah. So they were like text-based games, but like real-time online that you played with multiple people. Okay. Long history. There's still many in operation today, even, but they're not nearly as popular as they used to be. A very, very niche thing. But I wanted to learn about messing with embedding scripting languages in Haskell. So this server embeds Lua in Haskell. And I wanted to mess around more with STM, Software Transactional Memory, another acronym for you. And build like a multi-threaded server that can, do stuff like this. So yeah, that's what we're working on, what we're building, and what we're having fun with. Let's get to it. I gotta set up my environment here. I haven't fully done that yet, but here we go. We're gonna go to Bakamud. Bring up my editor. Get our builder going. GHCID. And then we'll get to it. Yes. We don't need to worry about those warnings. It's fine. Okay. Yeah. So last week we got functions from Haskell functions, added to the Lua stack, so we can call Haskell code from Lua. A while back, we got the opposite going, so we were able to call Lua functions from Haskell, Lua code. I wanted to get output working. It's like an output stream for the simulation to like send, or like for the server to send data to the user and their connection, send it out to them through their connection. So we're gonna try and get that going, and then maybe we'll put a little Haskell API around it so that the game developer can write some code that would send data output to the user. Right, so I was talking about maybe using some kind of output buffer, sort of like logging, or no, channels. Let's talk about using channels for this. And we updated the state, did a little refactoring last week, where we wanted to change the way the connections map was stored in the server state so that it used a STM-ified container map, a map, basically, that can understand software transactional memory updates, because the data structure I'm thinking of using for the output of the simulation, or for the output that you want to send to the client, would be some kind of like logging type or event stream kind of thing that a bunch of subscribers would listen to, and that might be an STM data structure. And all the listeners listening to those changes off of that thing are going to be doing this in an STM transaction. And they're going to want to send data to the connection. They're not going to want to do that in IOs. You can't do IO things inside an STM transaction. You can only do STM things inside an STM transaction. It's just how STM maintains its guarantees, right? Because if you could do arbitrary IO in the middle of them, then it can't guarantee the safety of the transaction that it's attacking. So, some limitations. So I decided to do that refactoring there, make the connections map a software transactional memory structure, and I abbreviated it here to SMAP. And learn about focus. An interesting idea for an abstraction. Not really sure why it's there, but it is, and that's what the library uses. Software transaction STM-enabled containers, the STM containers library. So yeah, it uses a very generic way of doing map updates using this focus thing. So we got that working. The next step is to update the simulation state stuff and give the output system to the connection. Somewhere to put stuff into the connection. So yeah. Maybe I'm taking too big of a leap here with this design, but I was kind of like on the fence about it actually even last week with the channels thing. I'm still kind of like humming and hawing about it. I've been humming and hawing about it all week. Channels, great for chat servers. I'm kind of curious how they would work well for this idea I have of the simulation having like this event log as an output, basically, like an event stream as an output, and making that event stream like a channel. Because there's going to be, the idea I have in my mind is that there's going to be multiple readers of this, well, channel or stream, as I'm using kind of interchangeably here. I'm going to use event stream to mean what I mean, the idea I have canonically anyway. The implementation of which might be a channel. Because there could be, I'm thinking there would be like one thread reading this channel per connection. So that the connection can listen to all of the event streams, all the events that happen in the simulation, and pick out the ones for the connection it's interested in, right? That it's responsible for. Right, so when it sees an update from the simulation that affects the user's avatar that is in the simulation, the connection knows about the user's avatar that they're associated with, and go, aha, you know, do the update for that and put that content out to the user. Is that the best architecture? Not sure. Not sure. It might be an architecture. One idea we might want to try here. The reason why I'm like kind of worried about channels is, and then I guess we're going to find out is, do they support multiple readers? Now we have something like a broadcast channel that kind of does something like this. But we want to make sure that all of the connections, all the things that are subscribed to this event stream, listening for these events, can read from it without removing that element from the stream for other things listening, right? So it's kind of like the difference between a queue and a stream, right? A queue has a dequeue operation which removes an element from that data structure, right? And then passes it off to some of the code that reads it and does stuff with it. An event stream, you know, a read operation just reads the data item out from the stream, but doesn't remove it from the data stream. Right? Presumably at some point in time, that element might be removed by the stream itself. As new events arrive, for example, older events will get kicked out of the stream. Right? So like some kind of like circular buffer kind of thing situation. But yeah, so I want to figure that out so that we can do that. Maybe though, what I should work on here is put this on the back burner, the simulation output, and just have a way of sending output to a client, some output, anything, right? And then whatever we set up can use that functionality, right? We have a bit of that at the moment. We have what's called in the connection. I think it's a network connection. A data structure, like a queue for holding that output. And we have some client code to broadcast, to talk to the broadcast channel on that connection. Each connection is a broadcast channel. And put a message on it. So we kind of have a way of writing to the output, to a connection, writing some output to a connection. Okay. So I'm actually not too far off. Okay, so let's just hop over to the simulation thing and just see how it goes. Simulation state, output channel. Can T-chan can control the concurrent SDM T-chan deliver an item to multiple consumers? Or does reading a value remove it? Okay, they have an operation for it called peak. Or try peak, which doesn't retry, and peak retries until the transaction, until that T-chain is available, and there's nothing else locking it, basically. Which could get problematic, right? So we would probably use try peak T-chain in a loop if we're using a channel as a poor implementation of an event stream, for lack of a SDMified circular buffer. A try peak T-chain. So a try, it does not retry. It returns nothing if no value is available because it's locked. Still not great, because right, if we try to peek it and we get nothing, oh no, actually wait, so peak change just gets into the, so what I was thinking anyway is that like the transaction could be, the channel could be locked by another transaction, right? Someone else peeking it, for example. And if this is an output stream from the simulation, it would be kind of nice if we didn't have to lock it in order to read from it. Not gonna lie. So I'm wondering if maybe we should take like a mailbox sort of kind of pattern where there's just one thing that consumes the events from the simulation, the things that have happened this tick, and delivers that to the outboxes of wherever they need to go. All right, so it's probably got some kind of, it's probably got access to the list of available connections on the server that are connected to the simulation and waiting updates, that sort of thing. In which case, it could be the only consumer of the channel. And we wouldn't have any contention for peeking at this from multiple threads. It could just be one thread delivering to multiple places. That would probably be the better design. Yeah. What's up, Coolmitter? You have volume? I'm still quiet? Okay, my bad. Let me get volume up and readjust the position of my mic. It's probably that. Because I use a dynamic microphone, it's not super sensitive. But I have to make sure I'm positioned well for people to hear me. Okay, hopefully that's a little better. So yeah, I'm just ranting about architectures for this part of the server where we have the simulation running a tick update, a bunch of times a second, and things have happened in that tick. And we want to send that out, the output of those events, to the various connections that are awaiting to see that output. Like all the connections that are connected to the server in order to see to play the game, right? And so I think what I'm settling on is that we have this out channel, which is where we'll collect all the simulation events. And we will have I was planning on having like multiple threads reading from this as like an event stream kind of situation. But the operations that I'm looking at here, like peek that look at the channel without removing the item, would still like be a STM transaction. So they would lock your T-chan until they're done with that atomic transaction, and then the next thread would get to read from that, kind of forcing potentially contention for reading from the simulations output, which is not something we want to have to deal with in the server. So I'm thinking maybe we do more of like an outbox sort of situation where we have a single thread reading from the output of the simulations events channel and delivering the updates to the places that have asked for them. Right, so we have some kind of like subscribers type system that like makes sure that all the connections say, hey, I'm interested in getting updates about this. And then in this mapping, the output thing can look at, the output process can look at the output channel of the simulation and go, okay, yeah, I've got updates for you. Here you go. And that is how we can deliver updates to the connections. So right now we have like a simulation event that is just a client has connected that we could do. And we'll probably have a bunch of others. But let's just start with this and try and get it to work and see if this is a good structure. All right, and we have the simulation state out channel also in a channel there, so that's good. Then we have to get the simulation to update in the tick to send this event to that out channel when it happens. Okay, this might not be a good event, but I'm just going to put like maybe a test one here. The something happened event. Oops, something happened. I'll just put text. Sorry, that's a type. I'm getting ahead of myself here. So then we need to import data.txt. We don't have that type here. That's all fine. We compile again. That's happy. Okay. So the something happened event. Let us. So this is the simulation loop here. All right. It's not doing anything. This isn't the final form of it yet or anything like that. All this code right now is doing is doing this in a loop. It's loading the main mud module, which we don't really actually need to do in the loop, but it's doing it. We're getting the Lua interpreter state. We're doing stuff with Lua, basically. All right. We push this function onto the stack. The Lua stack. We execute that main module, that Lua in the Lua interpreter, and if everything was good, then we call tick. Okay, no, this happens once. We call tick. Tick is where the main loop happens. This is all set up. Oh, good. Right, so we get the current time, last time, and all that stuff. Game loop stuff. Okay, so in here is where I'm gonna like just ask for the simulation state. What am I going to call it? Server state, simulation state. And that's going to be a hole because that doesn't exist on the server state yet. Here's a question about boundaries I'm now thinking about. Do we want to, or should I have like a separate monad for running our simulation in that's separate from like this Bakamud server type? Right, because this monad here, monad, I don't know, is like a very simple reader monad that just has like this giant state data structure in it that has like all the variables for the whole server. And we could, what this line I just added here on 57 is doing is like asking for this value out of that state. So we could basically make the simulation state a variable in there that we want to grab. We'd probably put it in a tvar or something like that. And what that means is that doesn't mean a whole lot because we're writing the server here, but like it just means this function here, tick, would also have access to everything else in the server, like all the other variables, the global connection map, the whole 9 yards. And I don't know if that's like super important that we separate out those things. All right, but it like could have the server support, and it could ask for the command queue, and it could ask for the Lua interpreter state if it wanted to. Obviously, I'm writing the code, so like I can make sure it doesn't, but I don't know. We could also make another monad here and run it inside of a Bakamud server monad. And that way, it only has to worry about simulation state stuff. And we'd have to write an interface for asking to actually get like anything else in the Bakamud server context and run it inside this monad. All right, so if I wanted to do it that way, write the simulation type for it, basically. I give it 2 type parameters, an M and an A, conventionally monad and whatever you're returning. The return type. Might even make that a new type, or follow the MTL kind of setup here. And what does it get simulation? Well, it could be state T. Right, with our simulation state over that M of A. We have to derive a few things, like applicative, functor, not eq, no. Don't really need an applicative functor, which will allow us to derive monad, which we need. And then we could do monad state of simulation state. All right, we don't have that in scope, but that comes with a library called MTL, so we can get that. No, control, so data state, control.state. Like control.reader, we do import control.state. And I have a typo there, we can fix that. Okay, so now we have this thing, right? Yeah, what can I do with this? Well, I can write a run function for it. That is actually going to execute the state T somehow. And what is it going to return? Probably something, just the result. All right, the simulation state is only interesting to the actual computation of computing the next tick. So you give it a run simulation function. It's going to take our simulation MA, probably a simulation state to kick it off. And return that MA. All right, so that initial state is going to be our argument. And then we have this function left that we have to apply, we have to create to fill in this hole with. A simulation MA to MA, this part. All right, so all we're going to do is pull off the simulation with get simulation. All right, and then we're going to do something else. Now we have a state T in this hole. Well, we can execute a state T with functions from control.mono.state. Run state T. But that needs more arguments. I'm gonna backward that. No, it's not run, it's eval. Well, we need to add a little context for that M type parameter in the function signature, so I'll add that there. Okay, so now in this hole, we just have simulation state. Well, we have one of those, it's initial state. Cool. So that's how we create the runner function that can run a thing that returns a type of this. That could be cool. We could move some of the stuff that we put in Bakamud server, like that is just purely for the simulation to run, like this nanosecond stuff, which is the server tick timer and such, into this part, and we can remove that from the server state type there. So we could do that, but I'm going to do that in a separate step. I'm not going to do all of this at once because I want to get this back to compiling as quick as I can before I go and make another change like that. Right, so instead of just tick L, we're going to run simulation. Tick is going to be our function. L here is our Lua state. Okay, so we need Lua state, I guess, in tick because we're going to be running user code in the tick. Yeah, so that could also be moved into our simulation state type. The only problem with this is that our game server, our server state, also owns this thing called the Lua state, the Lua interpreter state, and we only want there to be one, and we don't want them to be messed with concurrently. Like we don't want any concurrency. We want every access to that thing be protected. So instead of getting the raw Lua interpreter state, we should actually pass in a reference to that channel, or that the STM var that's protecting that interpreter. Lua interpreter. And I think, if I recall, that is kept in a tvar. Let's see, yeah. And I'll call Lua state. I'll actually prefix that type there, so it's state's a very overloaded term. It gets used a lot. All right, and yeah, that's because it's the wrong argument there. I'm gonna flip those around. Okay, so now in this hole, in order for this to compile again, we got to put a simulation state. All right, so we're gonna have to construct one of those probably in here. Okay, so this code here gets the Lua interpreter state. So we're getting it out of the reader T here from the server. And this atomically, every time you say atomically, this is a function from STM that initializes a transaction. So you know there's a transaction on some variables here. In this case, we're going to be reading the T-bar of the Lua interpreter state. So we're going to be reading it. All right. This code is still kind of hinky because we're actually modifying that Lua interpreter state outside of this transaction. And if there were other threads also reading it and then pulling it out of that T-bar and then doing stuff with it, right, they could also be modifying the interpreter state. If they tried to put that interpreter state back, right, that could be bad. We could override each other and fight each other. Unfortunately, this simulation function is trying to set up some interpreter state when it starts up, which I think maybe in a separate refactor I might want to move that higher up in the call graph here and set up the interpreter state from a higher level. I think this is just leftover vestigial test code when we're messing around with the Lua interpreter, so that'll be fine anyway. But just for like future note, right? So this read T-var is fine and stuff. I'm just reading it, but like I should be using this T-var and using this variable inside this transaction block. Now that the reference, the value it was holding inside that T-var is outside of the scope of that atomically, down here I'm like pushing code onto it and calling stuff. And another thread that's trying to read that could be reading that interpreter state is going to see a different one. It could see a different state. All right, so I'm going to put a little to-do note in there, remind myself to fix that. Remove this. Initialize interpreter state. Fire up. This is leftover prototype code. Okay. So let's get back to where I was, which is that server state, that initial server state, simulation state. We could do simulation state. We need a couple of values there. We need a T-chan for the sim events, the output channel. We can create one here. Output channel. Right, and that comes from the new T-chan IO. And that's going to be lift diode. Okay, and then we can put that in here. I'm going to use named arguments for these because it's just cleaner. And just make A's for readability. Mix out my names, but it'll get fixed. The outchan. not outchan. Consistency helps with that sort of stuff. All right, and then our simulation state. Other thing that I forgot already, because I had the memory of a fish some days, Lua interpreter. Okay, so that needs the TVAR state Lua interpreter. We asked for that earlier. L. No, that rated out. LTVAR. LTVAR. Like that. Okay, so now we have the whole for that simulation state. We have that in scope. It's in its simulation state. Okay, and now 68, we have the problem of Lua state to Bakamud server. It wants a function. Oh, tick is, we got to update tick's type. So it's not longer going to be that. We're just going to rip this out. It's going to be a simulation unit. There we go. We got to remove the argument. And 73, yeah. So no longer need to ask for the simulation state here. It's like part of our state. So now we have some key call stuff in here because we were like doing some of the Lua interpreter that used to be passed in as an argument. So we'll have to bring that back into scope in order to get this to compile again. Which is essentially what this code up here did. Again, not super safe. Although, I think we're going to probably remove that code anyway. Let's, LTVAR isn't in the scope because we need to bring it out of the state, so we can get that from the state with the get function from control.monad.state. Lua interpreter. Okay, and these functions down here now are like, this is all the wrong type, brah. So we're gonna fix those as well. The monad is no longer Bakamud server. It's going to be simulation. And on 93, tick doesn't want that. We can just return tick. Now we have the age-old problem of, like, we couldn't deduce monad IO in simulation. So I don't think we added it. And then we have some reader-based code asking to do reader stuff. So this is where we actually might need to do some of that moving of variables to this type. Or... No, let's do it now, because that's part of the change. Okay. So, I'm going to go into state. And I'm going to look for the last time. We need sim time rate. Delta time acute in milliseconds. Yes, I think we need all of those to be in our now simulation state. So I'm going to rename all of these prefixes. We'll probably get rid of the sim part. Yeah, format that's a little nicer. And then we have to update our initial state setup and all that stuff. So that used to be initialized by init server state. Those two. So I have to do that here. And accumulating T-bar there. Okay, and yep, these names need to be removed from here because we're using them. On the state side, so this one, that one. Okay, so we don't have to get system time. That came from, I think it was an import function for data clock.system. Time, not clock.system. And that can't, okay, so we need to lift IO this because it's not an IO function, but we have access to IO from the monad below us. So we're going to pull that up and lift it up. And then on 67, same thing. And this one as well. And some vestigial reader code. All right, so we're going to get that now from the simulation state last time. No problem. Same with this one. And the accumulated time as well. And we've got cannot deduce monad state. Simulation, yeah. Oh, is it? I'm probably using the wrong function. Gets. Yeah, sorry, it was gets, not get. Get gets the whole state, which is this expression here is getting like we just want a specific field. Using a function to get the specific field out of the state record. Okay, and now some vestigial imports in simulation. Let's see, 19. I thought we wanted this one, but maybe we don't. Well, start time VR is going to be used. Yeah, so we just need to, it's Probably getting confused because we didn't actually use it here, but we need to. Start time. Okay, last time rate delta accumulator milliseconds. We want to start time p-bar. And the delta time accumulator. QMS. Hello, August4444. Welcome to the stream. First time chatter. What's up? How's it going? Do you do Haskell programming or just curious? Yeah, what am I doing? Cool. Well, if you have any questions about anything, feel free to ask. I don't mind. I like answering questions and all that sort of stuff. About Haskell, about MUDs, programming in general. It's all welcome. All right, and we have one more field to initialize. Time rate. And the init server. What did we initialize that to? Should probably look at the diff. 1. So we can just hardcode that to 1, I guess. For now, it's probably got it. Yeah, to set this. Or set this from configuration. Okay, we're compiling again. I like that. Okay, so that refactor is done. And now our tick runs in this simulation monad instead, with its own kind of local variables separate from the main server state. Let's just run the server and make sure that all works. Even though the server isn't 100% working the way I want it to, it should. Because I did a bunch of other stuff that I kind of jankily ripped out that I need to put back. That I forgot to put back. I haven't done that yet. So let's do that, and I'll run Bakamud. But we should at least see the initial, like, hello from Haskell stuff from the Lua interpreter running our Haskell code. You're just starting to get into programming? That's great. And you only heard of Haskell, and you're just starting, you've heard of it already? That's very cool as well. Wow, welcome to the stream. That's exciting. You have a wonderful, wonderful journey ahead of you. Programming is awesome. So are you learning from school or self-interest, or what's got you on this journey? Okay, so I'm going to commit that because I think that's probably pretty, at least I'm satisfied with it for now. Seems to kind of work. Oh, yeah, of course, my silly environment. Causing problems. School and self-interest. Cool. A good combination. Scheme. I like Scheme. I like Lisp, so I've done a little bit of that myself over the years. Purely out of interest and for funsies. Well, welcome to the stream. If you want, you should check out the link above my head too. There's other cool streamers doing stuff in other programming languages. We all kind of gather on declarative.tv, and it's a cool little website we put together. There's a link to a Discord there as well, if you're interested. Check that out too. More people to follow, doing things in languages like Haskell, but other ones as well, that you might be interested in hanging out with. So where was I? We were building the simulation. We were about to commit the code, that's right. Bakamud / simulation.hs. So this, when applied, Shane's going to modify that file, and we're refactoring simulation variables into simulation state. It's more like changed. Added. Simulation monad. Changed tick. Run in simulation monad. Cool. We refactored tick to run in a dedicated simulation monad so that we can have a we can contain the simulation API to interact with the relevant part. No, we really did it so that we can set up the foundation we need to do this like outbox pattern. I wanted to experiment with. We're delivering simulation updates to connections. Okay, there we go. Okay, so next, now we need to take that hacky, fun little simulation event. Something happened. Right, I want to deliver it to the outbox that we're going to deliver things to. Right, the simulation channel that we set up. The outchan. So how do I deliver messages to that out channel? We've got write a value to the T channel. Yeah, that's it, write T chan, okay. Simple enough. Now that's going to be an STM action, so we're going to need that in atomically. So we're going to lift IO atomically. Do. So need some arguments there. I'm going to get GHCID running. Tell me what I need to do. So we're going to give the channel there. So we're going to get that channel. I'll call it outchan. Gets simulation state outchan. Now I have that in scope. And then I need a simulation event. We know how to make one of those. We'll just use the raw constructor right away because we're just testing this out. Yeah. It was simulation, something happened, text. Testing outbox pattern. Oh, a midget has noticed that we have some redundant imports I forgot to remove, so let's go fix those. That probably should be included with the last commit. So I will do that now quickly before we go too much further and get these things mixed up. Rebase, squash. Oh, no, I'll rebase. Reword that one. Got to remove that. There we go. Oh, that's better. Okay. Just edit that little commit before we push it up. Make it look like we knew what we were doing the whole time. Okay. Because we did. We did, eventually. Know what we were doing the whole time. Right. Simulation. So we get the output channel. We... And anatomically, we write to the T channel, something happened every tick. So that'll, if we compile this and run the server, that'll just continually deliver this output to the output channel constantly until we run out of memory. I think we have bounded channels, but I don't know if we want to use one for this. So, but we're going to need a thread that's going to read those off the output channel and do stuff with them. This can be like our output deliverator thread. So let's add that. Probably as part of the server. So we handle logins, handle some of the login commands. State. Maybe lower level, the network server. This is where we start a lot of the threads and kind of the main entry point for the server, so it probably makes sense to put it here. Okay, I'm going to call it... I think this is also where we start the simulation thread too, if I'm not mistaken. We call fork Bakamud. Which calls talk. That. I'm making a game. Yes. Yeah. So it's a multi-user dungeon type thing. So it's it's a online game you can play with multiple people at the same time, right? But it's text based. It's a very old school kind of thing. It was a precursor to what modern day people understand and know to be like massively multiplayer online games. Right? This is how we used to play them. We didn't have like computers that could do fancy graphics and real-time stuff at the pace and the speed and the amount of data you would need to do that for like your typical extraction shooters these days. But you could send text back and forth fairly quickly. So we did it that way. There's still some running to this day. Like, there's some commercial ones, like a Chia, Dreams of Divine Lands, by Iron Realms Entertainment. And it's free to play. There's ways to play it online without like on the internet, right? With a web-based kind of client, but you can also use a client you can download and install on your own computer. There's lots of free ones available. There are a bunch of others, and the basic idea is that like you type out commands that you want your character to do. The game gets commands from other players, also runs a tick, right, which updates all of the monsters in the simulation, right, mobiles, various other things that you've interacted with, and then gives you the output, what happened. You swung your sword, did it hit the monster or not, that kind of thing. Or if you sent the look command, what do you see, that kind of stuff. And because they don't have graphics, they just use text, they can get away with some pretty interesting and fairly deep simulations that would be fairly expensive to produce with a graphical client and a graphical kind of style game. And a lot of these games have been like in development for decades at this point, so they have like very, very sophisticated systems and can be very, very fun to play if you're into that sort of thing. It's not for everyone, but yeah, I'm doing it in Haskell, one, to like play around with some ideas and some libraries and just to mess around. And thanks for the follow. Appreciate it. So one of the things I wanted to mess around with in Haskell land was like, can I make a server application or like a Haskell application and embed a scripting language in it to extend to said application and be programmable by the user at runtime. All right, so I'm using Lua for that in this project. So far, so good. And I also wanted to like just mess around with a large scale application that uses, or large-ish scale application that uses STM, which is Haskell's software transactional memory library, which is great for writing concurrent networked servers and concurrent applications. Yeah, just seemed like a fun little project for the stream. Maybe one day, once it's getting nearer to completion, we can start actually developing the game part. And, do some Twitch integration, integrate with the stream and have some fun with it. Yeah, just learning stuff. Having fun messing around with it. And actually what it's like to program it in Haskell, well, you can go back and watch my VODs on my YouTube channel. That's if you go to agentultra.com or you follow me on the Fediverse, you'll find links to that YouTube channel and see what it is like. But to save you hours of viewing, I would say it is interesting. I like programming in Haskell. I think it's got a lot of good libraries and good support for this kind of thing. Sometimes it can be a little bit frustrating in some ways. One of those ways that I encountered that's a little frustrating is monads. They're blessing. They're great. It's a good, cool abstraction. It's a very simple pattern once you know it, but it's hard to explain it, so it confuses everybody. But if you can work your way through it, it's pretty cool. There's just some restrictions when you start using them, and you want to like compose programs out of them that can shoot you in the foot. So for example, this type here, Bakamud server, is an example of a monad I use here. All right, and I was trying to implement something called the reader T pattern, which is a kind of way of structuring Haskell applications that comes highly recommended by lots of folks, or some folks. And unfortunately, there are certain patterns that you use with the lower level networking library that run in just plain old I/O, which is a different monad. And I'm trying to do higher level MTL style reader T patterns with this low level I/O type thing, with forking and bracketing to protect all these runtime resources and make sure that we shut down these threads cleanly, that don't compose with the reader T pattern very well. And so I have to like write these kind of like ugly helper functions that nobody is, like very few people, unless you read the code and really dig into this, you're going to look at this and go, why though? And it's because of that, which I'm not a super fan of, but there's probably a cleaner way of doing it, maybe, that I don't have the knowledge for yet. But that was my attempt at solving it. And that can sometimes be a little bit frustrating with Haskell. But what I like about the plus side, the bonus side of it, is that like you get a lot of really dynamic and interactive feedback during that process. So it wasn't too hard to figure out. It was just ugly code. But I'll take ugly Haskell any day. I can deal with it. I can live with it. You know. But in languages like C++, it's harder to tolerate ugly code, I find. And you have to be a little bit more disciplined about it, because that code can get messy quickly, and when it does, it's, I think, a lot harder to refactor than it is to refactor code in Haskell, for example. So, I don't know. I'm rambling at this point. But that's how I think about it at the moment. Hopefully that helped answer your question. So, let's see, we're delivering that now, so we need to start a thread to read that output channel, and I'm just going to like log the results or something, you know, just to see that that works. So we're going to go pretty low into the network level. Let's see, loop. We get the connection, and the connection on the TCP server. This is where we fork the simulation thread here. Okay, so just a hard fork of the simulation thread. This isn't the best architecture either for this code at this point. I was just like blasting stuff out to prototype it and get it going. We should probably fix that eventually as well. Because this, if the simulation thread like throws an exception, this main thread here running this function isn't going to know about it. And it's just going to die. So we need to add something that handles that, which I bumped into a couple times while implementing some things. So now I'm going to add to this chaos and forego good advice and fork another thread. And we're going to fork that, I don't know how to put brackets there. I don't know if I have brackets on that. What are we're going to call it, we'll give it a function here, which is going to run in our thread. Yeah, I'm going to call it simulation outbox, for lack of a better term or name. I'm not even sure I'm going to keep this code around, so I'm just going to call it that for now. And if I like it, then we will revisit it. Okay, so we don't have that function yet, so let's go implement that. All right, so like what Haskell's telling me right here is useful information. It's like, here's the function, the name you gave me, but here's also its type it needs and everything, right? It's super useful. Love it. Error messages are great. I always live in errors when I'm programming Haskell. Or like, I like to create an error and then fix it, and then create another one and fix it. It's kind of my approach. There's only one other language I've used where I've used that similar kind of pattern, which was Pharaoh Smalltalk. Allows a kind of a similar style of programming. So simulation outbox has to be a Bakamud server of IO some type. We're going to just put it unit. And if I leave that undefined, it should just compile and be like, all good, yeah. And then I could put a hole here, right? And now Haskell is telling me like, hey, you need to put something of this type here, which isn't super useful to you who are just learning, but can be useful, because if I had like an arrow here in my type, I want an argument int to and return this. And then if I just put that hole there, it's like, hey, I expected a function with this type. So to get rid of an arrow, I just have to take an argument. Right? I can either follow that literally with lambda syntax and be like, okay, x arrow wall. For some reason, internet. Anyways, I can put x arrow hole, or I can put like x underscore here. Well, it's sorry, it's not. It's complaining at me now because it's a different type error, and it's ruining my beautiful, you know, digression here. Because I call it up here without an argument, but if I like gave it an argument now, I'm like, okay, one, whatever. Right. Put a hole here. It's like, I want an int. I want to get rid of an arrow. I can put like x arrow. This is like the lambda function syntax, right? And then there's like just convenient syntactic sugar for that. I can put the x on the left side of the equal sign, same diff. Right, now I get just a whole Bakamud server value out, right? I don't want that to take an x, an integer, as an argument though. Holes, I just love holes. I love showing people holes, and they're just awesome. They're just great. Okay, so what can we do now with this hole? Well, funny, we can use do notation here because we're in a monad now. And out of our simulation outbox, right, we need that channel that I created in the simulation. This, I think, is actually where I am now going to be annoyed with myself for this architecture, because we separated out that thing and now the server doesn't hold the outbox. I put that in the simulation. So either we need a way for Bakamud to get to that thing in the server, which we can't get to, or we have to hold it higher up here in the server state after all. Because I put that in simulation here. This tchan sim event. Which is convenient, I think, for running the simulation itself to put stuff on it, because we just have the right tchan here. This code. Write something to that channel in the simulation code. But now we have another part of the system that is outside this thread that wants to access that variable. So access that out channel, so deliver it to other parts of the program. So yeah, the server state needs to own that and have it. We'll have to figure out if we can have one reference to the channel, but pass that variable to the simulation. think we should be able to. Server state simulation outbox, outchan. I keep calling it outchan, so I'm gonna stick with that. We don't have that in scope, but that comes from Bakamud simulation. So GHC ID just crashed on me because we have a circular import error, probably. We do. Import server state here. In simulation, and in state we import simulation. That's okay. We can break the cycle by moving sim event to another module that both of them can import from. Well, I'll call Bakamud simulation event. There. Just cut this here. Pop that there. Add it to the imports. And that'll be fine there. We're going to fix that here. We're going to import the connection ID type and the text type. And then accidentally close my editor with a good old finger slip. Simulation, and we got a server. This server? No, it was the other server. Simulation, yeah. That was this server, right? Oh. Yeah, jeez. It's not quite all good yet, cause simulation outbox is fine. State. Teaching sim event, that's right. This one imports simulation event, so they can have the T-chan there. Type some type that doesn't exist. It's not loading that module. There we go. There we go. Okay. And back to server. Okay, so now in the simulation outbox, what can we do? Well, we can hopefully... Oh, wait. The other part of this we need to figure out is giving the out channel to the simulation state when we construct it. So the simulation, this function here still runs in a Bakamud server, so we should be able to get that from this and pass it in here. Normally I might write some kind of constructor function for this, but I'm just going to do this this way for now. We're going to be outchan. We want to read the outchan there instead of creating it. Server state, out channel. It thinks this is a whole. Oh, because we're not using the right name. Simulation outchan. You can name your holes, so sometimes that shows up that way. When I use this underscore pattern for naming record fields, which isn't required in Haskell, it's just a convention. One that I'm not really exploiting, so I might actually remove it from this code, but if I start to use lenses, I might want to keep it. But I haven't yet, so I don't know. On the fence about that. Okay. So we pass it, we get the outchan from the server state. And now we pass it into the simulation state when we construct it. So they should be the same thing. Now our simulation outbox should be able to ask for it or get it. Outchan. We don't have that in scope. So let's get it. Control.monad.state. Oh, sorry. Simulation outbox is still in Bakamud server. Oh, where am I going with this? Must be getting late on the stream. 9:36. Here we go. Okay, let's get back into it. This is getting outchan from the server state. Simulation outchan. There we go. So now that outchan is in scope, we should be able to read from it. So let us. We got a loop. We could just do forever, which will just run as fast as we possibly can. Which we're gonna like maybe do a thread delay so we don't do it super fast, but I think it's like thread sleep or something. Oh, what is it called again? Thread delay. There we go, that thread delay. All right. Control.concurrent. That has to be lifted into I/O. I have to lift that from I/O. Yeah, imported data is not needed, thank you. Okay. So to that out channel, we'll write, or no, we read tchan. That will give us a sim event. Right? And that has to be in a transaction. Let's just print it out, like debug. Okay, that all compiles, so it should probably work, right? Well, hopefully. Not always. Let's run it. Let's see what happens. Am I going to cook my computer? Ooh, that's an interesting error, and not one I was expecting. A linker error. These garbled names are generated by the Haskell compiler when it gets to this link stage. It might, not typical, but they do happen sometimes. It might be that show, maybe we don't have a show instance on the sim event. Usually we do have show. Sim event, undefined reference to it. Undefined reference means you can't find this name it's looking for. Do we import it? Okay. We need the type to show that this is actually a sim event. Otherwise it wouldn't know. I'm going to use type applications to try and convince. Add a little annotation. Right now I think Haskell's just getting a little confused. It knows the type of the channel, so it knows that it should be outputting sim events. But I'm just confused why it's missing the reference to the show instance for sim event. I'm guessing, I'm not really quite sure why that is. Oh, okay, now I know why. There it is. The compiler is trying to link together a bunch of modules, and it's not linking this module we're importing because it doesn't know about it. The build system, Cabal, doesn't know about it. So we have to do that. My bad. Now it should be able to figure everything out. There you go. Okay, server's running. This is great. Okay, we see that. I'm expecting to see our debug output. I'm not seeing anything. That doesn't mean it's not happening. It could mean just that the output handle like isn't getting passed through here, is not flushing properly, like the main thread controls that. Before I get in this forever loop, let's see, simulation outbox. Fork that here. Let me see if I can lift IO, put Sterlin, outbox. This is like printf debugging right here. Which is also something I do frequently. People say it makes you not a great programmer. I say they lie. Alright, simulation outbox. That's fine. So it gets there. So either there's T-Chan is empty. Nothing's getting on it. Alright, we could put this here. Run it. Yeah, and so it's probably locking for some items on the channel to be available when we go to read it. Well, that's probably what's actually happening. And why we don't get to debug event. Well, now it has no excuse. Thread delay. It should be microseconds, so 10,000 shouldn't be a problem. Unless I'm wrong about that. Maybe it's just not liking forever. Because I was expecting that to say a simulation outbox in our output like continuously. One other way we could we can typically loop, which is just recur. We do the sim event stuff again. Read T-Chan, out-chan, lift IO, put Sterlin. Go a sim event. That's also a way to recur and loop, and maybe we would see that output that I'm expecting. All right, that has to be read atomically. Okay, we get it once, but nothing. Okay, because we could be... Wait, we're still getting simulation outbox. Printed. Interesting. Maybe I'm getting a weird build state. Let's clean. No output now. All right, so if we are blocking for the sim event, that would make sense. And if we comment this out and just lift IO, put stirlen, and run. Yeah, we should see that continuously. Okay, so we are blocking it on the read from the teach-in, which means we're not getting any sim events put onto it. Okay, interesting. Might be a bug in the tick loop or something that I need to fix. So let's uncomment that. We'll go back to simulation, look at tick. Let's see if we can figure out what's going on. So we should be writing to it all the time here. Let us do some good old print debugging here. Tick begin. Okay, we get one call to tick begin and nothing else. That should be calling constantly in a loop. We should be getting that constantly. Let's see if we get this far. I don't think any of this code would block. Okay, so we get to that part. And we can't do an IO action in here. We could break the rules a little bit and put a debug trace in there if we wanted to. We got to import the debug up here. Okay, there we go. So we're locking right as we go to write to the teach-in. Why are we locking? Because we're locking the threads, they're competing, right? They're atomic transactions. One transaction has to complete before another one's allowed to modify whatever's wrapping that STM variable, right? Have you spotted it yet? I wonder, chat? Right. It's the answer is one or the other thread, basically. The one that's either reading from this channel or the one that's writing. One of them is going to get there first, right? And they're going to block until they're done. And in this case, the reader is getting there first and blocking the write. Right? And so it's just the write is, now we're at a contention, basically, right? Contention issue. So now the write is waiting for that lock to come off, and the reader is going to wait indefinitely for the write, for something to show up on that channel. So the solution is to not wait. The solution is to use our non-blocking read from teach-in, which I believe returns a maybe. Yeah. So we try teach-in. We don't retry, so we don't hold the lock. And we got a maybe sim event. And so we can case match on that. If there's nothing, don't worry about it. No. When there is something, we'll print it. When it is just maybe sim event. This is just debug code, so I'm just gonna like show it. The whole thing. I don't care about unwrapping it. We should probably put our thread delay in here. That should fix it. Still blocking. Right T-Chan should eventually be able to. Because try T-Chan should just read it, and if there's nothing there, just return and let go of the lock. And not retry anything. Oh, sorry, try read T-Chan. But still. Let's see if we get here. We get anything? Simulation outbox, start. Okay, the thread starts. Try read T-Chan. Okay, we get there. But we don't get to actually read anything. Looks like we don't even get to the next line. Are they still contending? Right shouldn't be blocking either. Oh, we can duplicate a T-Chan. I wonder if maybe it's the references. the tick is... I would still expect if they were like the assignment I'm doing, or the assignment this code is doing when we're constructing the simulation state, right, is getting the channel from the reader T, the server state, right, and then constructing the simulation state, which puts into a state monad and executes that. This assignment here to this record field and passed in, I'm assuming is like still a valid reference to the channel. And like there's only one channel allocated on the heap for this value. And that writing to it in the tick function down here in the state monad is putting data on it, and our other thread, which also has a reference to this channel, you should be able to read from it, because it's this one and the same object. It's not creating a copy or a separate object. That has been my assumption so far. But I'm wondering if maybe that's not the case. And what we should do is duplicate the T-chan. I don't know if that really is the problem, though. Although... how could I verify that? We could maybe pre-populate or like bake in a sim event to when we construct the channel and just put some data on it right away before we start the server. Outchan. Oh, maybe I'm getting a warning I'm missing and not paying attention to, and that's the problem. So where is it? Here. How did GHCID compile without it? Huh, okay. Because we need to create that there, so... call it sim outchan. New tchan IO. Okay, that's redundant. That's redundant. That. Okay, fine. We'll compile again. 14 modules sounds about right. Okay, that's slightly different output. That's better. Kind of expecting more output than just that. Prog. Okay, so we weren't... For some reason, we were able to compile without actually initializing the simulate outchain. That's a little bit not right. Okay, so now that we have that... Fork this. Try read it. Okay, so let's... just that. Okay, and we're holding up again because get the service state, it's sim outchan. We try to write to it. Something happened here. And we try to tick again. Are we blocking? Okay, something's blocking. Okay, let's remove that and just tick end begin, and we stop. I think we should be seeing more tick begins and ends. Like, I think that should be happening continuously, constantly. Come on, everything. Okay, so something in there. Something in there is like doing something weird. With the time rate, last T time, these T bars, I guess. What's system time? Okay, so let's leave those comments out. Let's bring back this and the out channel. just that. We're fine there. I don't think we got our output that we're looking for. So let's get rid of this tick begin, tick end stuff. Okay. So we are getting our event for our channel, just something happened. Okay, so it's kind of working, but there's something messed up in here that's causing, excuse me, causing us to lock this tick thread. Maybe it's the Lua interpreter. Alright, seems to be. Okay. Alright, so we're gonna wrap up the stream, but we should do a little review of this like kind of prototypey hacky code and see if it's something we want to continue with and extend next week when we come back to this project once more. Okay, so something about running the Lua interpreter here is causing us to lock up. That's fine. This was all just prototype stuff. So I think maybe we could just delete this for now. I should clean up those warnings. Accumulation time not used. Okay. Time rate not used. Okay. Control.monad. And that should build cleanly now. There we go. Okay. August 444. That's to be expected, right? Like, how would you know? It's Haskell. You've never done it before. I hope it was somewhat entertaining or interesting, or maybe you have some questions that you might maybe want to ask next time or follow up on it in your own time. But if you go to the link above me to that declarative.tv site, there is a Discord server there. There's a community of folks. I hang out on that server, and if you think of that question later, you can ask it there. Or I'm also on the Fediverse. I'm on the types.pl server. I'm Agent Ultra there as well. You can follow me there for updates on this stream and just general programming nonsense that I do. Also my website, agentultra.com, and it's got links to basically everything from there. My GitHub, YouTube, where I back up the VODs for the stream, and such. All the code you've seen tonight is for a project called Bakamud. It's up on GitHub as well. I'm going to push that up. And yeah. I think, no, I'm not going to stage everything here. Unstage all of this. This needed to go in with this commit, I believe, right? So that was state.hs simulation No, okay, it goes in this one, I think. We didn't add the event module, right? Oh, that's in the next one. Okay, so that's fine. Yeah, let's just roll this. Okay, stand here. Stage, create a commit. But you are welcome. You are welcome. August, it's nice meeting you and hanging out with you. And thanks for watching. Really appreciate it for the follow. And if you got your notifications set up, you'll get notified when I go online next time. Otherwise, I regularly do these streams on Tuesday evenings at about 10 after 8 in the Eastern time zone. And if you don't have your notifications on, you can just remember that. And maybe we'll see you next time. You know what I'm saying? And then get more Haskell nuttiness. So we're going to add, the main part of this change is adding the outbox consumer. Modify Bakamud network server. Added simulation outbox consumer thread. Changed. Refactored some modules. Fix circular imports. Boom. Okay. Push that up on GitHub right here, Agent Ultra / Bakamud. I have a lot of other projects on there too, but if you want to give that one a star, like, whatever, you're good. That would be great. Follow along there. And hopefully we'll see you next week. Take care out there. Happy hacking. May all your monads be free and your types always check. And yeah, if things aren't going well, I hope they will soon. Take care.